Hello, everyone. Our talk is about securing process control data transmission to the blockchain network. Today, we're going to talk about blockchain integration to industrial control system. Why the ICS industry is taking too long to adopt blockchain, and how blockchain technology could have been a solution in speeding up the production of COVID-19 pandemic vaccine as a sample use case. So we'll talk about that later. But before all of those, let us first introduce ourselves. I am Ken Tugbo. I'm a former resource speaker and a college instructor. I am more on automation, instrumentation and control, system security. I'm also a certified architect, focusing in security as well. I'm a software security engineer in Amazon that develops hybrid technologies like distributed control system and SCADA. Today, I have my friend and colleague, Chimi Arian Hilis. She's currently working as a software engineer in Amazon as well. And her interest lies in ICS cybersecurity, vulnerability management, and application security. Today, our discussion will be subdivided in the following segments: blockchain demystified, ICS acceptance criteria, and etc. So let me demystify blockchain first. Before we go any further, let me explain what blockchain technology is and how it works. The original blockchain is open source technology that replaces the traditional intermediary for Bitcoin transfer. The ecosystem's collectively verification replaces the intermediary, increasing the traceability and security. Blockchain technology can now be used in private, public, and hybrid setup, as well as outside of the financial sector, which we will discuss later. So how it works? So if a transaction is requested, it is broadcasted to a peer-to-peer network computers. It is also called nodes. Then a verified transaction can involve cryptocurrency, contracts, records, or other information depending on the use case. Once verified, the transaction is combined with other transactions to create a new ledger of block. The new block is then added to the existing blockchain, which is permanent and unalterable. Blockchain technology is really hype right now. Well, in fact, aside from finance, we're seeing a lot of new games being developed in blockchain. Filipinos are one of the highest users of Axie Infinity. In fact, Axie Infinity is a crypto gaming platform. Its mission is to make blockchain technology accessible to all. It is actually built on Ethereum platform. It is actually a play-to-earn crypto. And Axie mechanisms reward players for interacting with Axie Infinity while also encouraging them to keep their tokens to earn more rewards. It also decentralized Axie Infinity in ownership and governance. So overall, they use blockchain for governance, staking, and payment. So not just for a single transactions. So to dismay the gamers, the cryptocurrency craze has led to an increase in the price of GPUs. Due to the worldwide shortage of the new and used GPUs, NVIDIA, the company that invented GPUs, announced a new line of graphic cards with reduced hash rates to make them less desirable for miners. And when I presented a similar topic in blockchain being overhyped last 2017, we saw back then that there's a lot of startup companies that are failing to penetrate the industry. We think this is because they just implement that without validating the use case. So, when implementing blockchain, it is very important that you know your valid use case before you can use the technology so that your startup company hopefully will be successful. So here we are showing you where is it worst. It is okay to use and technically the best purpose of blockchain. Since 2017, when I started to learn about blockchain, there's a lot of use cases we're seeing right now. Let's say, for example, in luxury items and art selling, we're seeing nowadays a lot of NFT use cases, like as you can see in the screen, Stephen Curry bought an art, technically an image, for $180,000. That's huge. Well, definitely you can copy that image and post it in your Twitter account, but you can't prove the ownership of that image. So basically, that's where blockchain comes in. Another use case is marriage. Couples choose this route, for them to personalize their vows. And finally, by scanning the QR code of your turkey, you can verify that it was raised on their farm or fed a specific diet. So, there's a lot of use cases for blockchain now, but we're still not seeing a widespread adoption for industrial control systems. Well, in fact, security is one of blockchain's benefit. Like it can guarantee validity and data integrity, as I mentioned earlier. But still, it's rare that blockchain penetrate the ICS, which we will talk about later on. It might be overhyped in cryptocurrency, and there are already a lot of use case available, but we're still not seeing adoption for industrial systems. So why? Okay, so um, basically, if your solution isn't broken, do not fix it. Technically, don't use blockchain in all area of your business. It is a technologically sound concept with, what we gave you a real world application, but it has very specific uses and not a universal solution. You know, People love to tell how great blockchain is, but that's because they never tried using it. Blockchain has become a buzzword nowadays used by companies to appear innovative. But do you really need one? Before you join the hype, take a look at the big picture. Do we really need blockchain for ICS? So for us, there should be general considerations like statefulness. Is there a need to store state in ICS? Assets are there any physical assets convertible to digital assets? Transactions, are transaction involved? If not, can the overall process be broken down into mini transactions, for example? Intermediaries, does removing intermediaries result in reduced costs, be in time or in resources for ICS? And finally, trusts, are there any multiple parties involved? Or are there parties which are untrusted for ICS? These are the general considerations that you need to check before considering the technology. And all of these general considerations are present in ICS. Thus, there's a benefit using blockchain in ICS. So for us to validate that use case, let me check that. So to further emphasize that, I will give you a sample use case. Yours truly is one of the inventors of this patent, which was granted to us last year by the US Patent Board. So our invention is called machine-to-machine transaction using distributed ledgers in process control system. So our invention will provide a trusted, secure, and immutable record of transactions within a process plant. There were techniques that we described there for utilizing a distributed ledger in process control systems, and the distributed ledger may be maintained by nodes which receive transaction broadcasted from the field devices, controllers, and what else? Operator workstation or other devices operating within the process plant. So in this manner, recorded process parameter values and product parameter values may be retrieved to verify the quality of the products. So the use case here specifically is regulatory data may be recorded in response to triggering events so that regulatory agencies can review the data. So the idea is blockchain can be used in a regulatory compliance purposes for ICS. We mentioned that it is the best use case for ICS. This use case used blockchain within the secure zone network of manufacturing plant, as you can see in the screen. We still have a use case outside the manufacturing plant secure zone. So let's have a typical example, an approval of COVID-19 vaccine. So some vaccines are still awaiting WHO approval, and one of WHO's requirement is vaccine manufacturing plants follow recommended manufacturing best practices. Let's use the storage temperature, for example. Wu monitored parameter, the vaccine storage parameter or temperature should be kept between negative 90 degrees Celsius and negative 60 degrees Celsius, and should be discarded if it is exceeds the set limit. Also, temperature record must be kept for at least 3 years for tracking purposes. So now, a blockchain network between pharmaceutical companies and regulatory bodies, in this case, WHO and FDA, will speed up the process and ensure the integrity of data being sent for approval. Okay, so another use case for this one is to ramp up equipment procurement, for example. In the event of manufacturing plant device failure, the system health is monitored in real time, and replacement device alarms can be set up. So once the request is made, bids can be sent out for evaluation to third-party contractors who provide these services. So as you can see, these are all valid use cases. So now that we have a valid use case for ICS, let's dive into it. Blockchain should not only revolve around finances and cryptocurrencies, right? In spite of valid use cases that we talked about earlier for ICS, we have not yet to see a blockchain-based regulatory use case in production right now, that will help ensure the validity and data integrity. So let's check for the acceptance criteria. So first, we are done on identifying the valid use case, right? We talked about that earlier. And we know that it is very important in applying blockchain. So we validate that the use case is definitely okay and best to use blockchain. Now, let's focus on security. As we all know, blockchain is infamous of its security technologies. And security is one of the main roadblocks for implementing blockchain in ICS. Why? Because there is a minor question to ensure the secure input of sensory data to the blockchain. How can we ensure the confidentiality of transmitting data hop by hop in the ICS networks, for example? So, overall, data security is the problem, since we all know that data is very important in industrial control systems. And, technology complexity is also a weakness, because right now, none of the blockchain platforms implements IoT-focused transaction validation rules and IoT-oriented consensus protocol. So the primary challenge is non-availability of the IoT-centric consensus protocol. These protocols are for embedded devices for blockchain implementation in an ICS network. We will give you details on that later on. We'll talk about some solutions for these acceptance criteria at the latter part of our presentation. And other factors such as performance, integration costs, data management, etc., are still considered for ICS industry acceptance, but we will not talk about that in details in this session. We will just focus on the security part. Okay. So let's talk about first why security is the main roadblock. Okay. We talk about data integrity, data privacy, and overall data security in general are all important for ICS. But why? So for ICS use cases, ensuring data accuracy and consistency throughout its life cycle is critical. Data privacy is important because it protects intellectual properties like formulas. It is very important for pharmaceutical companies to protect their formulas, as well as recipes when sending them over the network. So blockchain has existing mechanisms to solve these issues by using cryptography. And we all know that cryptography is the blockchain core, right? Making it immutable and reliable. So let's deep dive more on blockchain cryptography. Blockchains use asymmetric algorithms and hash functions, and participants get a single view of blockchain via hash functions. And blockchain, for example, use SHA-256 and above hashing algorithm, depending on the framework. And hash functions are vital in maintaining the integrity of the data stored inside each block, as well as linking them together. Okay, so any change to the block data can cause inconsistency and it will invalidate the blockchain. As well as digital signature. Cryptocurrency uses digital signatures, and we all know they are also used for multi-signature contracts and digital wallets, for example. Also, to execute any action from these multi-signature contracts, In digital wallets, multiple or different private keys must be, digitally signed as well. Dig deeper into the encryption part, we have encryption in transit and encryption at rest, both common practices in blockchain frameworks as well. TLS, for example, encrypts data in transit, as shown here. The example.com service, as you can see in the screen, uses both in transit and at rest encryption to protect user data. This message is sent over 3 hops, 2 secured by encryption in transit and 1 secured by encryption at rest. So this is a series of secured hops, and each hop is secured by different key. And each server along the path has a key for each hop. So there's a gap for that. Every server involved in a message transmission must bridge a confidentiality gap, a fundamental limitation of hop by hop encryption. That is every server in path of a message through example.com. It decrypts and encrypts as shown in the survey, as shown in the picture in server A. And so in general, it implies that a server attacker must sufficient privileges that can read Alice messages. Somehow, some of the industry accept these risks because there are safeguards to protect us from these attacks. While hop by hop encryption protects against network and storage attacks, it is insufficient to protect against attacks on the compute resources like firewalls, NASes, etc. that messages traverse, right? So it's possible for compromised compute node, like the firewalls, etc., in the system to expose every message that traverses it. So that's the problem for the hop by hop encryption. And we know that it's important for ICS to protect the data, right? So there's a solution like the end-to-end solution wherein it fills in the gap left by hop encryption. Blockchain nowadays don't use this. There's actually no implementation right now that uses end-to-end encryption. It creates a private channel that extends the entire path from the sender to recipient. And end-to-end encryption can be achieved in various ways. It can have a secure channel, can be built on top of, hop by hop encryption foundation as shown here in the slide. So within server A, the original message is not and cannot be exposed as a clear text, for example. Even full root and physical access to the server and database will not be able to compromise the message confidentiality. That's why end-to-end encryption is so popular for instant messaging apps like Viber, Facebook, etc. However, a challenge for end-to-end encryption for blockchain is that it creates a safe space for criminals to communicate where no third party can read or perform security checks on their messages. So in other words, the technology meant to protect millions of people and businesses also protect criminals. So there's an argument on that. So that's why some governments prohibit end-to-end encryption. But we still need to use that because it protects the data, right? So by comparing the two strategies for protecting user data, we can draw some general conclusion on this. On one hand, hop by hop encryption is simple and easy to use, right? It only requires the adoption of the existing mechanism for securing data in network and storage, which we can apply in blockchain. End-to-end encryption, however, on the other hand, provides all the benefits of hop by hop encryption, plus many more. Primarily, it secures user data from attacks on the compute resources, thereby closing the pervasive confidentiality gap. As a result, only those with explicit authorization can access user data. And it exemplifies the principle of least privilege. An attack at one layer can be mitigated by an attack at another layer. So combining hop by hop and end-to-end encryption is a full defense in-depth implementation somehow. So for ICS blockchain use case, we think we need to implement some sort of end-to-end encryption because data security is critical for ICS so that it can be accepted. And we need protection in each layer of the ICS network to ensure the data security. But the next question is, what is the best end-to-end encryption protocol for blockchain in ICS. Let me dive into that. So um, if end-to-end is the solution, are there any current end-to-end protocol that meets the ICS blockchain implementation? So we need to check certain criteria, like it should be easy to integrate, so it can easily adapt the blockchain implementation. Um, this is the main argument for blockchain somehow, especially the decentralization of the protocol. It should adapt blockchain as well. And the protocol should be secure and trusted with non-known vulnerabilities for the E2E protocols that you chose, especially if the protocols are open source. We need an active community. It is essential to have an active community to keep that going. And finally, ensure that the protocol is compatible with the ICS transaction, especially for IoT encryption. So with this key element that we chose, there are 3 standout end-to-end protocols that we chose to study. And as we saw, E2E are used in Viber and in Facebook Messenger widely, but the technology is not rampant again for blockchain. We know secure messaging system employs varying degrees of security principles depending on the protocol. These are vital when comparing secure messaging protocols or applications. So we examined the 3: Signal, OTR or off the record, and Matrix protocol, because they meet the main criteria, which are actually end-to-end encryption and decentralization, right? So these 3 should have end-to-end encryption and decentralization properties. So Signal has an encryption powered by the open source Signal protocol that keeps the user conversation secure. Off the record or OTR messaging provides encryption as well, which we will discuss later on. And Matrix is an open source project that publishes the Matrix Open Standard Protocol for secure, decentralized, and real-time communication. The conversations are protected as well by end-to-end encryption. So when we check on these protocols, we also found issues with them. There are properties that we study, and these are divided in these areas: security and privacy, usability and adoption, and group chat features. Off the record only supports one-to-one synchronous conversations, requiring users to be online, whereas Signal and Matrix support asynchronous conversation. The secure messaging protocols do not provide all the security properties, as you can see in table A. So there is a room for improvement for these protocols. And only Signal and Matrix satisfy most of the properties that we consider for this solution. So for this one, we can see that Signal and Matrix should be considered and should be checked for further analysis. So we check now for compatibility of that for blockchain. So we listed down blockchain-related properties and checked their protocol compatibility. So far, only the Matrix protocol can support public, private, and hybrid setup of blockchain implementation strategies. It also includes the support for permissionless and permission-based authentication, which nowadays blockchain also implement this kind of strategy. Again, we don't need new technology to close the security gap that we mentioned earlier. Right now, as we analyze these properties, so far Matrix is fully compatible for blockchain-based implementation. And we know we can use this technology to speed up, the adaptation of blockchain for ICS when we receive data from the manufacturing plant, right? It is in order to trust the integrity of data at the manufacturing plant, right? But at the plant level device, there's another problem for the plant level part. We have embedded devices at the plant level. We have nodes there. So we need to check what are the possible solutions. If we have now a solution for enterprise setup where we can receive data from the blockchain, how can we process that at the lower level of the manufacturing plant? So my friend and colleague will discuss how to send data to the blockchain using an existing solution as well at the device level or at the lower level of the network.
All right, thanks, Ken. I'll be taking it from here. Hi, everyone. I'm Chimi Aryan, and I'll be continuing this part of the discussion. So the use case has been described by Ken earlier, and we have seen how we can connect the enterprise network to external stakeholders via blockchain. As the picture slowly comes together, one question remains. How can we seamlessly integrate plant devices, or L0 devices in this case, into the blockchain network? But first, let me explain a common scenario in manufacturing plants. Nowadays, most factories use the Purdue Enterprise Reference Architecture, or PERA. The Purdue model describes an enterprise architecture's layers or levels. There are 5 levels in the Purdue reference model. Level 0, or the physical process. This layer defines the processes used to create or support the company's products. The next one is level 1, intelligent devices. An example of this would be a robot arm that positions and attaches a wheel to a shaft. And the next layer is the control systems, which is on level 2. This is where the physical processes are supervised, monitored, and controlled. On level 3, we have manufacturing systems. The performance management systems and data historians are frequently found here. Next, we have the business logistics systems for level 4s and level 5. Here, the ERP is the main system, setting the plant's basic production schedule and inventory levels. With the Purdue model as the reference, end users, system integrators, and OEM vendors can easily adapt it to their needs. Integrating these layers is difficult due to the multiple hops required to get to the next one, which may violate the requirements of a trustworthy environment if compromised mid transmission. We researched several options and settled on 2 technologies. First, let's start with E4. E4 was designed with a client server architecture for machine to machine communications. It uses a publish subscribe protocol where a client subscribed to a topic receives all messages published by the server on that topic. But E4 is still in its early stage and lacks one of blockchain's requirements, which is decentralization. Because the server that stores the client and topic keys is a single point of failure and could be compromised. Malicious clients may also ignore the remove topic command and continue to receive messages from the topic. To avoid all of this, all clients should have topic keys updated. Since E4 is an open source project and is still in its establishing stage, manufacturers are less likely to trust it as an integration solution for their devices. The next solution that we've looked into is FDI, or Field Device Integration. Fieldcom Group, an organization that maintains existing industry technologies like HART and Fieldbus, leads the initiative of developing FDI. Achieved in collaboration with major industry suppliers, it aims to standardize software and tool packaging and distribution. FDI offers end-to-end security and interoperability with major control system manufacturers. Because every layer of the Purdue model requires an additional component, manufacturers are moving to the more open architecture, which converges OT and IT devices via a second communication channel, which is mainly through OPC/UA. FDI supports natively HART, wireless HART, Foundation Field Bus, Profibus, Profinet, and ISA 100 field communication protocols. An FDI communication server may handle various automation protocols like Modbus, Ethernet, proprietary, or any other protocol. An FDI server uses an OPC/UA server to access non-native networks. FDI secures an end user's infrastructure in 3 ways. First, time stamping and digital signatures ensure that FDI device packages are genuine and have not been changed by the manufacturer. It facilitates the FDI package registration procedure that manufacturers must strictly adhere to. Since having a user interface presents a significant risk to the system, UIP is only optional and must function only in a sandbox environment. FDI also supports OPC UA security. OPC UA is the interoperability standard for industrial equipment. A secure communication mechanism between FDI servers and clients is then implemented. Here's an illustration of a device sensor. This will be integrated into an FDI host, which could either be a process control or asset management system, a device configuration tool on a laptop, or a handheld field communicator. The FDI host always supports all FDI device functionalities. The FDI package is at the core of FDI technology. Electronic Device Description, or EDD, comprises device definition, business logic, and user interface description, or UID. Imagine it as a single device driver that you install on your host to make your integration successful. The FDI device package defines which data, functionalities, and user interfaces are stored on the FDI server. Now, the FDI architecture is built on the OPC Unified Architecture, or OPC UA information model, which allows platform independence. FDI server imports FDI device packages into its device catalog and is in charge of handling all the inputs from the FDI hosts. Now, to connect an FDI host, each device must first be mapped to an FDI package. Example of these devices are the communication gadgets found on the plant floor. Now, all communications related processes and services are described and provided using EDDL code as part of an FDI communication package. Then, on the control layer, the FDI server executes and manages all tasks. Devices that connect to networks require hardware resources, which the communication server readily supports. And then, through OPC UA, the data is sent to the plant network for processing by FDI clients. To interact with devices in heterogeneous hierarchical networks, any communication hardware can be used. Now, let us now turn to Ken to help us complete the big picture on how we could securely connect L3 to the blockchain.
Thank you, Aryan. So yeah, as Aryan talked about earlier, we saw that FDI technology is capable of sending data from the L0 of the Purdue model to the L2.5 to 3 layer of the Purdue model as well. Then once we receive that data from L3, the matrix server will then receive that and process that, as we talked about earlier. But before we go on to the details of how can we completely integrate that in the big picture, we talk about matrix as a solution for an end-to-end protocol. And matrix has all of the qualities that we require for an end-to-end protocols for blockchain implementation. Again, matrix is somehow is a standard protocol for real-time communication. And they launched an end-to-end encryption called OLM. They can be implemented in web, iOS, or Android. And the platform underwent a full review of Matrix OLM encryption library. It is audited by the NCC group, technically. So basically, OLM encryption protocol is for peer-to-peer communications. The other protocol goes by the name MELG-OLM. Again, it is used for group chats and end encryption. Conceptually, it deviates quite a bit for OLM, as it contains some of modifications that it more suitable for the multi-device use case. Again, Matrix somehow is for group chat or one-on-one conversation, WebRTC, bridging comms, Internet of Things data, basically anything else which needs to pub/sub persistent data to the world, which we think it is very suitable for blockchain implementation. So as you're seeing in the screen right now, Matrix protocol somehow is federated. And federation allows you separate deployments of a communication service to communicate with each other. And Matrix provides open federation, meaning that anyone on the internet can join into the Matrix ecosystem by deploying their own server. So similar to what we checked on blockchain properties, Matrix also can be implemented privately or hybrid, similar to other, blockchain frameworks. So in the screen, here's a simple integration of Matrix. Can you go back on the previous screen, please? No, the other one. Okay. Oops. Okay, so let's have a simple integration matrix on this use case. Basically, uh, we will receive the data from the secure network of the ICS, as Aryan talked about earlier, right? Via FDI integration, we can ensure that the data from the plant is secure because it possesses all of the end-to-end encryption, digital signatures, all of the devices are signed as well, and we know that the integrity of data is somehow there, right? So when we receive the data, it is time for us to send that to blockchain. We can definitely send data to the blockchain without an end-to-end encryption. We can just use the typical encryption mechanism of any blockchain framework. For example, Serious or Ethereum, etc. All of the blockchain framework available there. There are a lot of encryption mechanisms that are available for these blockchain frameworks. So, for example, you will have a mobile app that will have a blockchain account that will send encrypted message using the SDK of the blockchain framework. But again, going back to our issue, it will not be secure and will not be okay for a typical ICS use case because again, the data integrity and confidentiality are needed. Somehow, there is a strict requirement for data confidentiality, especially for World Health Organizations, where if we will apply blockchain use case there, they need to trust that that data should be protected at all time, right? So with Matrix end-to-end protocol, we can integrate and develop a Matrix client app, and that will perform an end-to-end encryption and will send that data to the Matrix server. So that Matrix server will send the data to the blockchain network. So technically, that's the whole concept. So in our example use case a while ago, we talked about the pharmaceutical industry, right? So as you can see here, Matrix will be helpful on doing an end-to-end encryption across its clients in the blockchain, right? So this can be in private, public, and in a hybrid setup, depending on the requirement of the manufacturing plant or the World Health Organization or the Food and Drugs and the FDA as well. So this technology is definitely a valid solution for a blockchain implementation. Now, we can combine the FDA solution and the Matrix existing technology and create a big picture for that. So again, similar to what we have in pharmaceutical industry use case. First, we have our FDI registered temperature sensor at the bottom right, at the level 0 of the Purdue model. And the FDI, again, will ensure that the device package used to represent the sensor was registered under the FDI registration authority and therefore was not tampered or altered in any way. Let's make sure that the World Health Organization ensure that at the level 0 of the data, it was not tampered at all, right? So all of these data are being sent to the FDI server in the level 2, which then transmit the information to the FDI clients. Located in level 2.5 or 3, depending on the plant structure. I saw a lot of plant structure that they have 2.5. There are plant structures that they have level 3 of the Purdue model. So depending on the plant structure. But since FDI supports OPCA, OPCA is one of the biggest protocol for sending data in the enterprise level, we will utilize that as a sample protocol to transmit the information securely to the higher layers of the Purdue models. Inside the plant's enterprise network, there should be a server dedicated to communicate to the decentralized Matrix server via generic messaging protocol. Example of that, RabbitMQ, MQTT, etc. So through this connection, we could transmit the storage temperature to the blockchain while ensuring data integrity, which is again crucial in this scenario. Again, once the data is in the blockchain already, it is ready for approval, right? Once the WU actually requests the data from the blockchain for if they want to approve that data, for example, for the approval process. Once the data has been stored in the blockchain again, the government or the governing body can now check the data via their native Matrix client app. You can develop that using the SDK as well, and ensure with confidence that the data has not been tampered with. They could now move on to either approve or reject the vaccine batches, depending on whether the parameters have met the established handling standards successfully. For example, what we talk about on the temperature of the storage, for example, of the whole batch of that vaccine. And WHO decision is whether or not to approve or reject will be sent on the decentralized Matrix server as well, and eventually recorded in the blockchain. And for that purpose, the manufacturing plant can that data as well, can actually get that data as well, right? So they can validate that data and check if WHO approved that as well through their Matrix client app too. So what has to be done so that this kind of solution that we talked about earlier, we talk about this time, what can be done so that this kind of solution will be available and can be easily adaptable for blockchain implementation? Because right now we're not seeing this in the industrial control systems. I'm currently working in DCS and SCADA systems. We're not seeing this kind of implementation. And as a software security engineer, we think that we need to create a framework, right? We need to create some guidance on this so that everyone should adapt blockchain easily. I've been studying blockchain, and I'm kind of sad that there's no valid use case for blockchain specifically for ICS. So for me, there's need on the creation of the framework so that it can be adapted easily. So first, what we did is to have a valid use case. We talk about a solid example on how can we use blockchain in pharmaceutical industry, and there are a lot of use cases that we can do, and we need to somehow regulate these use cases on where and when again blockchain can be used. It is okay to use. It is best to use in this use case because again, blockchain is not always the solution for every problem. So we need to consider that. So we need to check on what specific area in ICS that we can use blockchain as well. Okay. So once we know that valid use case, we need to identify the risk. So what we did, we identified the security risk for that use case. So we talk about data security, data privacy, and confidentiality, right? So we need to identify the risks of that particular use case. Finally, we also check for security requirements. So, once you identify the risks on your use case, you need to technically have some sort of requirements so that you can solve this risk by identifying solutions. We talk about these requirements and we validate some technology integration for the following requirements. We use some existing solutions. Why? Because technically, if you want to have an easily adaptable implementation, we don't need to create a new solution or a new concept. There are a lot of existing solutions there. We just need to some sort of integrate them together, right? So we have an end-to-end solution suggestion on security data transmission for the requirement of level 0 to the level 3 network and some sort of level 3 to the blockchain network by using Matrix. So we also check some compatibility requirements. We don't need to, have compatibility issues when it comes to, E2E protocols, etc. So we check and validate some technology integration for these requirements. So we analyze E2E properties of instant messaging protocols because as we all know, instant messaging protocols are rampant in chats, in messaging apps like Viber, Facebook. So we analyze the properties of that if it is applicable for blockchain. So we also check these instant messaging protocol if they are okay with the IoT properties. At the lower level of the Purdue model, we check for solutions on that as well, as Aryan talked about the FDI and the traditional industrial devices. We also check on how can they adapt on these new technologies. So FDI solved these issues, as we talked about that earlier. And also we consider some existing security standards. Right now, we also need to consider to utilize standards available for ICS. There is a very popular standard, ISO standard, which uses the Purdue model architecture. So our suggested solution somehow for blockchain to be easily adaptable to ICS is to consider some standard already available for them. We talk about the Purdue model architecture, right? So the Purdue model architecture will protect data and have secure zone in the ICS network. So your solution somehow should consider this and should be compatible on this standard, as well as the SDLA standard that a lot of companies right now are currently using. This will help the integration to be easily adaptable for blockchain. And finally, we talk about some sort of governance compliance. We also must consider government requirements for blockchain, especially on implementing secure end-to-end encryption, since not all of the countries are okay with end-to-end encryptions, as we talk about on the one of the challenges of doing an end-to-end encryption. The framework should still be, again, drafted to have a favorable agreement between the regulation bodies. So these somehow are the building blocks for me or for us on creating blockchain security framework. There are many similar strategies and alternatives for matrix and FDI technology that are, still remain unexplored. But still, we believe that the solutions are capable of successfully adapting blockchain for ICS, utilizing existing technology, as long as they comply with the framework that we think they need to do, and the similar approach that we did as well. So although the ideas and solutions we suggested are purely focused on security, there are other factors to consider, such as performance, usability, and so on. But again, security is a critical component, and for us, a stepping stone for the ICS industry to use and adopt blockchain. If we can secure the data of the blockchain, then definitely the ICS industry will adopt this. And ultimately, we will look at the available technologies for completely integrating and using blockchain for ICS use case. This is to speed up the adaptation. We know that somehow the technology is ready to be implemented in blockchain. It is not a zero effort, right? But somehow there are readily available technologies that we can integrate that can solve the issues right now for blockchain. And we believe that establishing a blockchain security framework, as you can see here, for the ICS is somehow a vital component if we want it to be, part of the ICS industry. If we want blockchain to be successful, valid, and secure for ICS. Okay. So again, thank you very much, guys, and let me know if you have questions. And again, don't forget to hack the planet.